Good morning, class. In today's class, we'll be talking about what is called probability. Now, probability is simply what? A guessing game. We look at possibilities and amongst other things. So now let's talk about probability. I have what? P of A. What is the meaning of P of A? P of A means what? Probability of what? An event A happening. Probability of an event A happening. So what's the formula? The probability of an event A happening is simply what? Number of favorable outcomes. Number of favorable outcomes over what? Over the total number of possible outcomes. Now, what do I mean by number of favorable outcomes? Number of favorable outcomes in this case means what? The number of what? The number of outcomes that will bring about what? Event A. The number of time event A will occur over what? Over the total number of what? Possible outcomes, the total number of possible outcomes. Now, this will make more sense when we drive deeper into probability. Now, before we go deeper into probability, I have to talk about sample space. Sample space. I'm sure you must have heard of it before. Sample space simply means what? It means what? A set of what? A set of the total possible outcomes. Now, your sample space is the set of what? Total possible outcomes. Before you solve any probability question, you need to take into consideration your sample space. You need to know the meaning of what? Of your sample space. Now, let's take an example. Let's take an example. Let's use a coin. We all know a coin, Abby. Now, the total number of sample space for a coin. The sample space for a coin is what? Head and what? Tail. When you toss a coin, you either have what? An head or what? A tail, Abby. You can't have more than these two. So the total number of possible outcomes in this case is just what? It's 2. Do we get it now? So your sample space is just what? Is the total number of what? Of possible outcomes. That is the meaning of your sample space. Let's take into consideration a die. You know a die, a Ludo die. So if you throw a Ludo die, you have what? 6 possible outcomes, right? Of getting what? 1, 2, you either get your 1, you either get 2, you either get 3, 4, 5, 6. This is the total number of possible outcomes for what? When you toss a what? When you throw a die, this is when you toss a what? A coin. When you toss a coin, this is when you throw a what? A dice or a die, anyhow. So now let's calculate. If I'm asked, find the probability of getting an egg. Now let's take a question. Find the probability of getting an egg when a coin is tossed once. I hope you can see that. Find the probability of getting an egg when a coin is tossed once. Now, I've told you your probability of getting egg is simply this formula: the number of favorable outcomes over what? Total number of possible outcomes, which is what? Number of times you get your A over what? Your sample space. Do you get it now? So now if I toss a coin, I either have a head or a tail. Now, head, if I toss the coin and I happen to have a head, it appears just once. I'll be out of what? What is the total number of sample space? 2. So that tells us that what? The probability of getting an head when you toss a coin is just what? It's 1/2. And 1/2 is what? 0.5, right? Which is what? If you multiply it by 100, you have what? 50%. So I have 50% chance of getting what? Of getting a head if I throw a coin once. Now, let's talk about the range of a probability. Now, a probability is what? 0 less than or equals to what? P, or should I say P less than or equals to what? 1. What does this mean? 0 here means what? The events never occur. Whenever you have 0 in probability, it means what? The events never occur. Whenever you have 1 in probability, this was the events always occur. the event always occur. Now, this will make more sense if you are dealing with more examples. That tells me that what in a probability I can never have more than one. I can never have an answer to the two. It means you are wrong. And in probability, I can never have a negative answer like -2. Remember, the least value is what? 0. The greatest value is what? 1. Now, let's talk about 2 coins. When I toss a coin 2 times. Let's clean this. So now, let's assume I tossed 2 coins. Abby, this was 1. Let's assume I tossed 2 coins. Now, the sample space for 2 coins will be what? Now, this is where tree diagram comes in. What is the meaning of tree diagram? Now, this is my first coin. Let's assume this is my first coin. Let's assume this is my second coin. Now, if I toss my first coin, I have probability of getting what? Head and tail, right? Now, the second coin, this is where the tree diagram comes in. I do something like this. What's the meaning of this? If I toss this second coin, I have probability of getting head and tail. And what? Head and tail. Do you get it now? Now, what's the meaning of this? What is the total number of sample space in this case? If I toss 2 coins at the same time, I have probability of getting what? Head, 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 tail, head, tail, tail, head, tail, head, tail, 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 tail. So what is the total number of possible outcomes here in this case? It is what? It is 4. Do you get it now? So if I toss 2 coins, I have probability of getting what? Head and head, head, tail, tail, head, tail, tail. This is what? 4 outcomes. Now, let's go further to 3 coins. What will it be? What would that be? This is just the cheat, 2 raised to power 3. Why did I say 2 raised to power? 2 raised to power 3 will give me what? 8. That means what? If I toss the coin 3 times, I will have what? 8 possible outcomes. Now, let's confirm that. S equals what? Now, the same thing, we use this tree diagram, right? Let's use this tree diagram. And this is for the first coin. And this is for the second coin. Have you seen it now? Now, because I'm dealing with what? 3 coins, I will have more than this tree diagrams. I will provide more. So this is it. Have you seen that now? So I also have what? Head, tail here. Head, tail. Head, tail. Head, tail. I hope you can see that. So now, if I toss what? 3 coins at the same time, I have what will be my sample space? This is my sample space. My sample space will simply be what? Head, head, head. I have the possibility of getting what? 3 heads. Or what? Head, head, tail. Head, head, tail. The next thing is what? Tail, head, head. Tail, head, head. Or what? Tail, head, tail. Okay, tail, head, tail. I think I'll put this one. Head, head, head. Head, head, tail. Then what? The next one is what? Head, tail, head. Okay, sorry. Head, 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 tail. You have what? Head, tail, head, head, tail, head, head, tail, head. And the next one is what? Head, tail, tail, head, tail, tail. Then I move to the second one. Tail, head, head, tail, head, head. And the next one is what? Tail, head, tail, tail, head, tail. And the next one is what? Tail, tail, head, tail, tail, head. And the last one is what? Tail, 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 tail. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8. I have what? My sample space is what? 8. That means what? I have what? 8 total number of what? Possible outcomes. It can't surpass this 8. Either I have this, or 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 I have this. So now, when we are dealing with more questions, this will make more sense. Now, one more thing I want to talk about for probability is that what? Let's talk about what is called what? Complement. Now, what's the meaning of complement? Now, let's look at this probability. The probability of A happening is simply what? 1 minus what? Probability of what? A not happening. What do I mean? This A prime you see here is called what? Either prime or complement. Now, probability of me getting an head is what? 1 minus probability of me getting what? A tail. Do we get that now? probability of an event happening is equal to what? 1 minus probability of that event not happening. We get that now. Remember, I told you, you can't have more than 1 in probability. So that tells me that what? If I look at this set now, if I look at this set, this is probability of A happening. I mean, everything inside is. Probability of A not happening is what? Everything outside is. Do we get that now? Probability of A not happening is everything outside. So that's why I have what? Probability of A happening equals what? 1 minus probability of what? A not happening. Do we get that now? So that is all we need to do with probability. So let's take some examples. Let's take some examples. Let's take some examples. So now, one example. Let's take an example. Okay, let's look at the first question. First question, let's open to page 68, number 18. Page 68, number 18. Now, the question says, 2 dice are thrown. Abi, 2 dice are thrown. Remember, whenever you are starting a question, you need to know your sample space, the total number of possible outcomes. So 2 dice are thrown. What is the probability that the sum of the 2 numbers obtained is greater than 10? The 2 numbers obtained is greater than 10. Now, how will I get the sample space for 2 dice? Remember, a die has what? 6 total number of possible outcomes, Abi. So 2 dice will give me what? 36. Now let's confirm that. Now, how will I get the sample space for 2 dice? I'll do something like this. 1, 2, 3, 4, 5, 6. You can see I'm not using the tree diagram. That one is only applicable to what? To the coin. So now in this case, I have also 1, 2, 3, 4, 5, 6. This is the first die. Dice or die. This is the second one. So now, if I throw 2 dice, I have possibility of getting what? 1, 1, right? If I throw 2 dice, those that play Ludo as well, you have possibility of getting what? 1, 1, or what? 1, 2, or what? 1, 3, 1, 4, 1, 5, 1, 6. Or I have the possibility of getting what? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So now, if we are to count the total number of possible outcomes, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Some total is what? Is 36. That tells me that what? That my what? The number of my what? Sample space is what? 36. That means what? I can only have what? 36 possible outcomes. The total number of possible outcomes is what? 36. Do we get that now? So if I throw two dice, I have what? 36 total number of outcomes. Now, the question is asking us that what is the probability that the sum of the 2 numbers obtained is greater than 10? Now, if you add these 2 numbers together, will it give us 10? No, this will simply give us what? 2. This one, 3, 4. So we will look for the numbers that if we add them together, it will give us what's greater than 10. So now let's look for that. This will give me 8. This will give me 9, right? This will give me what? Greater than 10. Sorry, so we can't sample 10. This will give me exactly 10. So I need the ones greater than 10. So I'll pick what? I'll pick this. What else? Greater than 10. I'll pick this. This one is also what's greater than 10. Is there any other number greater than 10? No. So I have what? That tells me that what? My sample space is what? My probability of what? Of getting numbers greater than 10. It simply was the n of what? Of getting number greater than 10 over what? The total number of your sample space. Abi? So I have what? 1, 2, 3. 3. What is the total number of sample space? 36. 3 over 36. And we can see that that's equals to what? 1 over 12. 1 over 12. That's option A. Option A. So that tells me that what? The total number of what? The probability of getting what? Of getting a number greater than 10 is simply what? 1, 2, 3. It's 3 out of what? 36. Do we get that now? 3 out of 36. So I have 36 number, total number of answers. Now let's take a look at another question. Okay, let's take a look at another question. Question 50, page 54, question 53. Page 54, question 53. Now, suppose that P is the probability that an event occurs. P is the probability that an event occurs. And Q is the probability that the event does not occur. Q is the probability that the event does not occur. Which of the following is true? Now, the first option tells us that what P equals Q. This is never true. Do we get that now? Remember, I told you the highest number you can have in a probability is what? Is 1. And the least number is what? 0. 1 means what? 0 means what? The events never happen. 1 means what? The events always happen. Now, we are told that what? The probability that an event occur. Let's call that PA. The probability that an event A occur. And what? The probability that the event does not occur. Let's call that what? P A prime. Remember, I told you A prime means what? A complement. The event does not occur. This one means what? The event occur. This one means what? The event does not occur. Is equals to what? If you add these two together, you cannot get more than what? 1. 1 is the greater value, in probability. So that tells me that what? We were told in the question that what? PA, the probability that the event occur is what? Is simply small p, Abi. And we were told that the what? The probability that the event does not occur is what? Is Q. So I have what? P plus Q is equals to what? Is equals to 1. That's option B. P plus Q equals to 1. P times Q does not make any sense. And P times Q equals 1. This is also wrong. So this is the correct option. So now let's take a look at another question. Then we have an classwork. We have a classwork. So now let's take a look at another question. Let's open to page 71, question number 73. Page 71, question number 73. Now, the probability of getting a number greater than 4. The probability of getting a number greater than 4 in a single throw of a die. Now, in a single throw of a die, what is the total number of samples? Let's even talk about the sample space. The sample space in this case is what? Total number of possible outcomes, right? So if you throw it that, you either get 1, 2, 3, 4, 5, 6. Can't get more than this. So the number of sample space is what? 1, 2, 3, 4, 5, 6. 6. You get that now? So now the question answers, what is the probability of getting a number greater than 4? A number greater than 4. Probability of getting what? Getting number greater than 4. Probability of getting number greater than 4. To give me what? Probability of getting number greater than 4 is what? Probability of getting what? Total. Okay. Let's not write that. So let's just go straight to the point. Probability of getting number greater than 4 is what? What are the two numbers greater than 4? 5 and 6, right? We count that 1, 2. 2 over what? What is the total number of sample space? 6, right? Over your total number of sample space, 6. So 2 over 6, if you divide, here 1, here will give me 3. So I have what? 1 over 3. Do we get that now? Option D. Actually, it's option D, 1 over 3. So the answer is option D, 1 over 3. So do we get that now? Now, let's take a look at, okay, let me give you classwork. Let's see if you get what we were saying so far. Let's do some work. You can see the question on the screen, page 96, question number 16. Page 96, question number 16. Two fair dice are rolled. Two fair dice are rolled. What is the probability that both show up the same number? What is the probability that the same number show up when you throw the two dice? So let's do that. You guys will be unmuted.